Okay, so this problem, which Dr. Stevens uses with the table, we can also do with that David Lang normal curve problem. Okay, so we're looking for what z-score cuts off the bottom 90% or the top 10%. I mean, you want to do the top 10%. So instead of having to go inside a table and look for that value, with this calculator, we want a value from an area. We know the area is 90%, so 0.9, and then the mean, that we're on the standard normal curve, mean of 0, standard deviation of 1, and we want to go below, because we know 90% of it is below, so that's the z-score, 1.282, and if you compare that to Dr. Stevens, 1.28, he rounded, so okay, so that's why the calculator sometimes works a little better. So let's look at this. Whoops, let me come back to it. So for this your turn, I don't know if you tried this, but since I'm here, I want to know the z-score that marks the 25th percentile. In other words, is 25% of the distribution is below it, 75% of it's above it. So we can come right back to that calculator. Make sure you have value from an area, because our area is the probability. Area under the curve, if you looked at calculus. So that's the z-score that cuts off the bottom 25%. Now, actually, if you think back to what we did in chapter 2, this is actually the quartile of the normal curve, right? So when a standard normal curve is z-score of negative 0.674, cuts off the bottom 25%, the normal quartile. The upper quartile will be the positive of that. See how that is? They're symmetric. So that means it's 50% in between. So the inner quartile range will be 6.674 minus a negative 0.674, or we can just double that value. Don't need to do that. We don't need to know about that. Okay, but I wanted to just point out this calculator. So value from an area. If we're looking at like if we go down to the problems, the problem set in the book, I would scroll down using the quicker method, but this for some reason this PDF on this computer actually wonky. So you're gonna have to wait till I scroll down. Okay, we're in the normal approximation of the binomial distribution. Let's see, like this one here. This is one of those summary worksheets. See how we know the top 10%? We want to know what IQ qualifies students to get that. So it's that we're looking for a value from an area, but we don't even need to use a z-score for this, because we can just go to that calculator. Here, let me open it up here, my paper copy, so I don't have to write anything down. Let's see, page 98. Come on, open up. Top 10%. So we know the mean's 100 and standard deviation's 15. So I want a value from an area. The area is 10%, so 0.1, and the mean is 100, and the standard deviation is 15, and we want above the top 10%. So they have to score on this, for this distribution, they have to score an IQ of 119.2. I think those are integer values, so probably 120. That's how that works. Very easy compared to the z-scores, and this is perfectly acceptable to use on exam. I would just want you to screen capture that and come up. Now, if you're going to use value from an area, it's the same thing. That'll tell me I know the mean, I know the standard deviation. I'm looking for a value. Okay, I'm looking for an area here. So they'll tell me the probability, which is an area. Okay, hopefully that helps.